Hello everyone, welcome back to the latest lecture session. A quick recap of what we have been up to in the last session. We started discussing about the different water quality parameters, and before doing that we also looked at why is it that we need to look at these parameters in particular, let's say. Right, let's have a quick recap of what we have been looking at. When we are talking about water quality parameters, we are limiting ourselves, at least in this course, to a handful of parameters. Obviously, there are a lot of parameters, but with respect to the general wastewater treatment for domestic wastewater, we are limiting ourselves to only a handful of parameters. More or less, we are trying to ensure that there is enough dissolved oxygen or satisfactory levels of dissolved oxygen in the stream that is going to receive our waste or treated waste. So, let us say this is the stream or the river and my treated or untreated waste is coming in, right. So, I want to see to it that the dissolved oxygen in this particular river throughout this stretch or throughout the relevant stretch is acceptable. Why is that? Again we discussed this. Why is that? Because higher forms of aquatic life must have dissolved oxygen to live, and at relatively low DO levels or no or anaerobic conditions, you are going to have septic systems prevailing or septic conditions prevailing, and you will have also pathogens prevailing during that time, relatively greater prevalence during that time, right. In general, high dissolved oxygen content is, I guess, an indirect indicator of decent quality of water, right, decent, not good, I guess. So, water pollutants, we talked about a few aspects. Obviously, organic matter. So, organic matter can be oxidized by microbes in the presence of oxygen to CO2 and water and other byproducts, let us say. So, we are concerned with organic matter, but we do not directly measure it. There are ways to measure it, but we do not directly measure it. We measure it in terms of oxygen demanding material, right. And then nutrients, typically we are going to look at nitrogen and phosphorus, and pathogens. So, microorganisms capable of causing disease, and suspended solids, right. We will look at this. I believe we started looking at oxygen demanding material. In that context, we looked at two particular parameters. One is the biochemical oxygen demand, BOD, and the other one is chemical oxygen demand. Right off the bat, you can see that in one particular variable or parameter we have this addendum or biochemical oxygen demand, the other one is only chemical. So, obviously, here we are going to look at the biodegradable fraction, right. Okay, here I have that amount of oxygen. Again, we are going to look at the amount of oxygen being consumed by the microorganisms as they degrade the or consume the biodegradable organic matter. So, three key aspects, right. So, a generic example here we have the microbe out here. Here is our waste, which is their food, and here is the electron acceptor, which is oxygen. I believe I already looked at this, so I will move on. The second aspect is COD. Why do we want to go for COD? The BOD test typically 5 days at 20 degrees centigrade temperature or 3 days at 27 degrees centigrade, but typically people go for this test, okay. And also it is not easily reproducible. The reproducibility, let us say, of this particular test is pretty low, depending upon who is conducting the test, and more importantly the kind of waste. Why? Because the kind of seed bacteria that you are using, again as we mentioned with respect to the BOD test, it is all about the microorganisms consuming oxygen while degrading the organic content or biodegradable organic content. So, the kind of microbes, the kind of waste play a role, and if it is not domestic sewage or wastewater from our kitchens and toilets and such, reproducibility will certainly be an issue, right. And obviously, as I mentioned, 5 days, so it is relatively slow, right. Thus, people would typically want to look at relatively faster methods. So, COD test, let us say typically 2 hours to maybe 3 hours, yes, so relatively fast. But here we are going to measure both the biodegradable and non-biodegradable organic content, let us say, right. So, that is something to keep in mind. So, how are we getting that done? If I use oxygen for this test for COD, it is going to take a lot of time, right. time kinetics, it is going to be very slow. So, we are going to use oxidizing agent which will lead to faster kinetics. So, what is the strong oxidizing agent we are using here? So, dichromate, right, and we are going to look at the amount of dichromate consumed in the oxidation of inorganic and organic matter, right. So, that is something that you need to keep in mind, and then the units are obviously though going to be in terms of milligrams per liter of O2, right. It is not of dichromate because we are going to convert using electron equivalents, let us say, right. So, that is something to look at. I believe stoichiometry, most people should be pretty familiar by that now. So, let us say you have a compound out here, this is not a microbe, and how much oxygen is it or oxygen equivalents is it that it is going to require, let us say. No microorganisms, that is the key aspect to keep in mind. So, why is it that I need to be concerned about this BOD, COD, and then think about spending money, time, resources to tackle this or remove this from the wastewater? Because let us say this is common in many regions in India or rather everywhere. So, you have a drain with untreated waste coming in and you have the river. So, color change, let us say I am not really concerned about that, fine. Turbidity is high here, relatively high, but I am not sure how high the turbidity is here. I mean relative turbidity is fine, let us not bother about that. But let us say I am a concerned citizen, but a selfish citizen, let us say, right, and that is what the society is about right now. But or at the end of the day, I am just concerned about how is it going to affect me, right, everything revolves around me, the concerned but selfish citizen now. So, the issue here is that one example is of Delhi, okay, Delhi, Mathura, Agra, Yamuna flows and maybe Etawah. So, upstream of Delhi, out here upstream, right, the quality of water is pretty good, but by the time it passes through Delhi or the National Capital Region NCR, the water quality is so poor that nothing survives in this water. During the summer season, it is more or less a drain with little to no flow, okay. Again it is a drain because partially treated or sometimes untreated waste from the surroundings, sometimes industrial areas come into this river Yamuna, and that is what comes to Mathura and Agra and treated and reused. But from what I know, this water even after treatment is not good enough with respect to, let us say, emerging contaminants and such, which we are not going to discuss right now, but people only use it for bathing or such purposes, but not for drinking water, I guess, or not for drinking. So, that is something to keep in mind, as in even though I might not be concerned about the long term effects, as in if I let this persist downstream of this junction of the river and drain, remarkable levels of septic conditions will prevail, or remarkably anaerobic conditions will prevail, and that is going to kill the ecosystem in that particular region, right. And you are also going to, let us say, affect the quality of life of the people around, and also let us say you are going to affect the not habitats, I guess, the fishermen and such, right. So, that is something to keep in mind. Again, whatever we discharge ends up being consumed by us, or let us say here we have the agricultural fields and this wastewater is used out here. Let us say we have these persistent organics, which I am right now calling as emerging contaminants, more of this later. For example, the pharmaceutical compound or let us say antibiotic I taken, only some of it, let us say 20-25% will be used or consumed by me or my body, and the rest is going to be flushed out through the system, urine or feces, and it is going to reach the wastewater. The traditional wastewater treatment, what do we say, plants with or when they are run efficiently can remove them to some extent. Again, here I am just using a very generic term, please note that I am just using emerging contaminants. Depending on the kind of emerging contaminant and such, that will persist in the even treated wastewater, and in untreated wastewater obviously the levels of these emerging contaminants are going to be high, and let us say if they are used in these fields, I am going to end up consuming them again, let us say, right. So, it is more or less a cycle. Whatever we put out there, it is going to end up affecting us. Similar, this is similar to air pollution. I emit, what do we say, air pollutants, I end up breathing them and my health is affected. So, these are aspects that we need to be concerned about. So, BOD test, how do I go about it? So, you can look at this particular video. Simple BOD measurement, again it is oxygen demand, let us see, right. Let us see how we are going to do it. So, measure dissolved oxygen of the sample. So, these are the BOD bottles, typically 300 ml, relatively standard sized. Okay. Measure the DO of the sample. As you can see, it is 0 day and it is 3 day at 27 degrees centigrade or 5 days at 20 degrees centigrade, right. The kinetics turns out to be the same. So, you will measure the initial DO and then the DO after 3 days or 5 days as you see fit. But where will you keep the sample in that time? You will put it in an incubator. Why? You want to maintain constant temperature, so that the rate constant of degradation of organics is constant, let us see. As you know, rate constant depends on temperature, so you do not want the rate constant to vary a lot. That is why you are going to put it in an incubator, and also no sunlight to prevent photosynthesis. So, after the relevant period you are going to measure the final DO, right. Measure the DO after 5 days or 3 days depending on the relevant temperature, and you are going to get the difference in, what do we say, DO levels, right. DO initial minus DO final will give you the BOD, right, biochemical oxygen demand. Here we are assuming that our sample, which is let us say domestic wastewater, already has enough microorganisms which are assimilated to that particular kind of waste. So, we do not need to add any further microorganisms, but if it is toxic or industrial waste where you presume that the microorganism content is going to be relatively low, you have to add microorganisms and also add the relevant nutrients to allow for the growth of these microorganisms, right. So, that is something to keep in mind. Let us just look at what I have here briefly. The BOD test employs bacterial seed if we assume that there is no bacteria or microorganisms in the relevant sample, to catalyze the oxidation of 300 ml of full strength or diluted water, wastewater. We will look at why we need to dilute the wastewater. The strength of the undiluted wastewater is then determined from the dilution factor and the difference between, as I mentioned, the initial DO and the final DO, right. That is what we have out here, and BOD with respect to either 5 days or 3 days is DO initial minus DO final. For example, initially, because microbial action has not yet started, let us say the DO might be, let us say 5 milligram per liter, and then I put it aside, I close it. Why do I close it? Because I do not want oxygen from the gaseous phase to replenish the oxygen in the aqueous phase, right. If I let this happen, then I cannot measure the change in, or the oxygen consumed by the microbes accurately, right. That is something to keep in mind. So, this is how we are going to do it. Let us say 5 milligram per liter initially and 2 milligram per liter after 5 days, and I am going to end up with a BOD 5, meaning 5 day BOD is equal to 5 minus 2, that is equal to 3 milligrams per liter, right, in terms of oxygen demand, right. So, in which cases will this not work now, right? Let us look at this. Do I have that? Okay, before I go further, when I say we are measuring the BOD, let us see what it is that we are actually measuring. On the x axis we have time, on the y axis we have oxygen demand. Again, I believe this figure is from the McGraw-Hill book, right, wastewater treatment, oxygen demand. So, if we have a sufficient number of nitrifying organisms present, nitrification can occur as shown by the dotted curve. So, here we have two aspects or two types of oxygen demand. One is the nitrogenous biochemical oxygen demand and one is due to the carbonaceous. So, nitrogenous meaning, let us say I have NH4 in my solution, let us say, right. It can be oxidized to NO3, right, oxidized. So, this also will require some oxygen, yes, but this will not take place when we have typically organic content or carbonaceous biochemical oxygen demand. This will kickstart, or the kind of microbes that can lead to consumption of this nitrogenous biochemical oxygen demand will only take place or will only thrive in the absence of the microbes that thrive in when you have these kinds of organic compound. And typically when we talk about BOD, we are typically only talking about this CBOD. Okay. So, that is something to keep in mind. So, if I want to prevent this particular nitrogenous biochemical oxygen demand from being measured, what do I need to do, right? What do I need to do? So, I need to add nitrification inhibitors, right? I am going to add some compounds that specifically inhibit these compounds, let us say, right. So, nitrification inhibitors are added to prevent measurement of NBOD during BOD experiment. In general, when will this come into play? Typically, as we see from here, within the 5-day period, we typically only capture the CBOD. But if the strength of the CBOD is less, right, and my 5-day period is this particular graph here will shift to the left, right, and then even the nitrogenous BOD will be captured. So, in these cases also you need to be careful, and you will have to add the nitrification inhibitors, right. As I just mentioned, nitrification is usually observed from 5 to 8 days after the start of the BOD incubation period. When sufficient number of nitrifying organisms are present, nitrification can also occur. Nitrification as an NH4 plus oxygen, I am obviously not balancing the equation here, finally ending up to NO3 minus, NO2 minus and then NO3 minus, right. So, but I do not want this particular data, I am typically only concerned with CBOD. So, that is something to keep in mind. Example here that we have is initial DO of sample is 8, final DO after 5 days is 2. What is the BOD of the sample, right? Well, that is pretty simple. BOD 5 day is equal to 8 minus 2, that is equal to 6 milligram per liter. But most water and wastewater samples have BOD much higher than 6 milligram per liter. Our sewage, domestic sewage is around 200 or 150 milligram per liter. So, how do I measure this though, right? Let us just see what the issue is if I try to measure it. Okay. Before that, I should have asked this question here. I would typically have a question here. So, I have, let us say, my wastewater and BOD itself is pretty high, 800 not 800, 200 milligram per liter BOD. This is the estimated one. I do not know this, I want to measure this, and I know that the dissolved oxygen initial is, let us say, already low because it is sewage, let us say 3, it won't be typically as high as 3 milligram per liter. So, if I conduct the test as I did previously, what do? I will take the initial measurement and after 5 days, but because there is a lot of organic content, the DO final will be 0, right, because all the dissolved oxygen will be consumed. So, well, the difference which is going to be 3, is that going to be my BOD, right? Obviously not. So, that is an issue, right. And also two aspects to keep in mind here is that if the DO final is less than 2 milligram per liter, okay, the test is not reliable. Why is it not reliable? Why is it not reliable? Because if the DO is too less, the kinetics that we presume when we are looking at or analyzing or considering or the assumptions we make with respect to the growth of the microbes, are not valid when the dissolved oxygen is so low. The kinetics are going to be affected. It is not going to be a pseudo first order loss, it is going to be second order and such, and thus your particular system is not reliable anymore. And obviously, if it is 0, you know that you can't really estimate how much was left or how much of the organic content is left, right. So, even if it is less than 2, it is not reliable. So, if it is the reliability threshold is 2 milligram per liter, so 3 minus 2 only 1, I can't really end up capturing the organic content here, right, which is almost 200 milligram per liter. So, how do I do that? So, to do that, I am going to dilute my wastewater as an, let us say, 100 ml of my wastewater. I am going to dilute it such that the change in the DO during my test is less than the acceptable value. For example, the maximum DO at a particular temperature, let us say 25 degrees centigrade, DO maximum is around 9 milligram per liter. Let us say, let us be conservative and assume 8 milligram per liter is the maximum. So, I know that the lower threshold that I am fine with is 2 milligram per liter. So, the maximum change during my BOD test can be, or maximum change in DO during my BOD test can be only 6 milligram per liter. So, I need to dilute my sample such that, again sometimes it is certainly trial and error, such that the DO change is not too low. If it is too low, again you are going to have errors in your particular analysis, or if it is too high, you are going to have issues with reliability, let us say, right. So, you will have to see to it that it is between 2 and 6 or 1 and 6 milligram per liter change in dissolved oxygen, and then you will be able to try to back calculate and get the actual BOD. Let us look at that. So, if the relevant compound or the organic compound is not in high concentration, let us see. So, then I can get this done. Let me see what I have out here. Okay, I seem to have the one for the dilution water. So, first I have to add microbes. Am I adding microbes out here? Let me see what I have. Okay, we have essential nutrients out here. Why are we adding the nutrients? Because you need microbes to thrive, right? Microbes in your BOD test to thrive. That is why you add these essential nutrients. And air, why are you adding air? This is, keep in mind, the dilution water. As I mentioned, if my sample strength is pretty high, right, what am I going to do? And this is in this beaker, let us see, right. What am I going to do? I am going to dilute it by bringing this out here, add only a little of it. Let us say this is my sample, actual sample, and the rest of it I will fill it with dilution water, which is what I have out here, which will have high DO, and almost 0 BOD, right. So, that the total BOD in this particular sample will be relatively less, right. My high strength wastewater is now only a fraction of this total what do we say, diluted wastewater, right. Again, for that I obviously, what do I need? I need this dilution water, pardon me, which is high in dissolved oxygen and almost has almost no BOD, let us say, or no oxygen demand or no organics. And also I need to add microbes depending upon what do we say, the kind of wastewater. So, here we are not adding the microbes, unseeded dilution water. So, we are pumping air in. Why is it? I want to increase the dissolved oxygen, that is why I am pumping air in, and glass container, and I am adding essential nutrients. And then this I will transfer it into my particular, this is this bottle, into this container, and then the test sample, this is what we have out here, the test sample, right, Vs containing organic matter and an adequate number of bacteria. I am assuming that this wastewater already has bacteria, that is why I am not adding any bacteria, right. This high strength wastewater having adequate number of bacteria is added. Volume obviously depends on the estimated BOD. For example, if the BOD is estimated to be 10,000, I am going to add much lesser, right. If the BOD is estimated to be, let us say, 200 milligram per liter, relatively higher. Again, we will look at a particular calculation, it should be clearer then. And as I mentioned, typical volume of this BOD bottle is 300 ml, and then the rest of this 300 ml is made up by adding this dilution water, as I mentioned. And now I am going to have a sample that I can use to test for my BOD, let us say, right. And how do I go about that? Okay, I guess I have another particular case, but this is what I already mentioned earlier, but I will just summarize here. If the DO of sample is 8, initial DO is 8, and after 5 days the final DO is 0, what is the BOD? As we know, simple calculation says that the BOD 5 is equal to 8 minus 0, 8 milligram per liter, but obviously that is wrong, because if it is 0, I do not know whether it is we still have organic content left or not, right, say, right. So, it is not reliable, and as I mentioned earlier, if DO final is less than 2, reliable measurement cannot be made, as the growth of the microorganisms is going to be affected. That is why, as we just discussed, we are going to dilute the relevant sample to decrease the concentration of organics or the BOD and to increase the final DO, right. We typically dilute the sample so that during the BOD test or after the BOD test 2 to 6 milligram per liter oxygen will be consumed. If it is too high, not enough oxygen. If it is too low, it is difficult to measure, right. That is why we say we have thresholds of 2 to 6. So, this is the case when I have to seed it, I am going to seed it with bacteria, right. Why is that? Because let us say my sample, let us say from an industrial wastewater, contains organic matter, but has no bacteria or has limited number of bacteria. So, thus in my dilution water I typically have to add seeded, or seeded meaning I need to seed the relevant dilution water with bacteria, that is why we call it as seed, and then we add the relevant nutrients. We then purge it with air, more or less we are trying to increase the oxygen or the dissolved oxygen in the water. So, as usual we are going to do this, as in if this is my actual wastewater sample, I am going to only take a little bit of it out here and most of it I will fill with my dilution water from here, let us say, right. All of this will be my dilution water. Because I am adding some seed, that itself can lead to some BOD, right. So, that is why I will also have a blank which is only the seeded dilution water. So, I will have to measure the BOD test for 2 samples, one for this and also for this, to check if there is any BOD in this sample also, not in this sample, in the seeded dilution water also, right. With an example it should be clearer. Let us see what we have. As I mentioned, what are we going to do? Seeded dilution water, we are going to what do we say, purge it with air and then add the bacteria and the nutrients, and in the meantime we are going to choose a particular sample volume based on the estimated BOD and put it into our particular BOD bottle of 300 ml. And why are we seeding it? Because we have no or limited number of bacteria, and then we are going to fill the rest of this particular BOD bottle with our dilution water. And because, so what is the volume of the dilution water? It is going to be 300 minus the volume of the sample, and then we have the seeded blank. To see if our dilution water itself has any BOD, we are going to run the test on the seeded blank itself, right. Even though we call it blank, we do not know if it might have any BOD which might affect this reading. That is why we have to measure the BOD of this particular blank 2 or the seeded blank 2. So, people typically look at what is it now, dilution formula and so on and so forth, but I am not one for mugging up formulas and such. I think one that floats around, or the one that people usually use, is based on the dilution factor or such. But again, we are people who are comfortable with using mass balance. So, our approach is always about mass balance here. So, BOD with dilution, we are going to look at the fundamental approach, as in how to calculate the BOD of your particular sample. For example, in this particular test, what were we doing? We were only getting or adding some sample and most of it was dilution water. But when I measure the change in DO, I am going to measure the change in DO for this dilution water, but I want to know what is the BOD of this particular wastewater that I am concerned with. So, how do we go about that? So, a quick recap: when BOD is greater than 8, we dilute the sample. Dilution water itself can contain, will contain nutrients for the microorganisms and also microorganisms if the wastewater sample does not have acclimatized organisms or microbes, right. Such dilution water is often called seeded dilution water, and such seeded dilution water can have some organic content or measurable BOD which will mess up our reading in this particular BOD test, right. So, now I want to have or need to take this into account. How do I do that? So, the aspect here that needs to be taken into account is that we can conduct the mass balance on BOD or the organic content, let us see, right. So, the principle here is that, or it is mass balance, right. So, the BOD in this particular sample plus the BOD in this particular dilution water will be equal to the total BOD measured in this particular seeded diluted wastewater, right. So, two aspects. What do we have? I have my wastewater, right. So, there is some contribution from this particular wastewater which is out here. Let me highlight it in a different color, right. Only some of this, but there will be some BOD or the organic content mass, but we will have to change the variables here from the wastewater, and some of it will be due to this dilution water, right, but the total will be equal to the BOD in this particular diluted sample, let us say, right. So, more or less that is the mass balance out here, right. This is a batch reactor, we are assuming that what is that, there is no mass coming in and going out. So, it makes our job easier. So, how do I get this particular mass of the organics? It is not BOD concentration, it is always on the mass. So, volume of the mixture or the diluted sample into BOD of the mixture, what will that give me? It will give me the total organic content in this system, total system, right, is equal to the contribution of the organics from the dilution water and the contribution of the organics from the what is this now, sample, now actual sample, right. This actual sample is only a tiny fraction. So, that volume of sample is this into the concentration of the BOD in that sample is this will give me the mass of the organics in that particular sample. Similarly, volume of the dilution water into BOD of the dilution water will give me the mass of the organics in the dilution water. But what is this going to be equal to? This is going to be equal to volume of the mixture into BOD of the mixture, which is what I am typically measuring, right. What am I measuring? It is going to be the volume of the mixture into BOD of the mixture, and I am measuring the BOD of the mixture. So, what do we have? Vm is the volume of the mixture, BOD bottle volume, which is 300 ml typically, volume of dilution water and volume of the sample, pardon me. So, this is Vs, this is what I know when I am conducting the test, and volume of the dilution water is obviously going to be equal to 300 minus Vs, right. So, what do I have? I already know Vm, I know Vd, I know Vs, that is what I am going to start with. And when I conduct the BOD test, what else will I typically know? I will know the BOD of my particular sample, let us say, not sample, the mixture. BOD of my mixture is what I am getting at. From the relevant test here, right, because we are going to conduct the BOD test twice, one on the mixture, this is the mixture, and once on the blank, right. So, from the blank I will get this BOD of this dilution water or BOD of the blank, and from this you see that I have only one unknown, which is BOD of sample. So, I will be able to get that, right. Let me just look at a question if I have one out here, okay. So, BOD test was conducted in the laboratory using wastewater being dumped into the river Yamuna. So, BOD test is run by adding 3 ml of wastewater to 300 ml BOD bottles. So, what is this 3 ml? It is the volume of the actual sample, right, and the volume of the mixture, total volume is 300 ml. The bottles are filled to capacity with seeded dilution water. If initial DO of the mixture in the BOD bottle is 8 and the final DO after 5 days is 2, what is the BOD of the wastewater, right. Assume that seeded dilution water has negligible oxygen demand, this makes the job easier. So, what do we have? We know that volume of the mixture into BOD of the mixture, right. This will give me the organics in the mixture will be equal to the volume of the dilution water into BOD of the dilution water plus volume of the sample into BOD of the sample, right. This is what I am actually trying to get at. So, from above or from the question, what do we have? We know that volume of mixture is given as 300 ml, and we see that volume of sample was given as 3 ml. Volume of dilution water obviously is then going to be the difference, 300 minus 3, 297 ml, right. Let me just check the numbers. BOD test is run by adding 3 ml of the actual wastewater to 300 ml BOD bottles. The bottles are filled to capacity, meaning the remaining is filled with or made up with seeded dilution water, and initial and final is given of this BOD mixture volume of mixture is 300 ml, 300 ml. This is for the dilution water, or sometimes people call that the blank, and this is for your sample, actual sample, right, as in here is the figure. So, if I have this and this, right, let me, so the sample is this fraction and the dilution water organic is this fraction, right, and the BOD of the mixture is this entire thing, right. So, that should hopefully clear up the issue for anyone who is still confused. So, 300 ml volume, ml into BOD of the mixture, what is it that we have? We know that it changed from 8 minus 2 milligram per liter. This is the change in DO. Change in DO is equal to the BOD, that is what we have. And here I have 297 into the BOD of the dilution water, but what do I see? We see that the seeded dilution water has negligible oxygen demand. So, it has negligible oxygen demand, meaning it is 0, plus volume of the sample we know is 3, and BOD of the actual sample is what I am trying to calculate. So, what do I have? BOD of the sample or the actual waste water is going to be equal to, this is again in ml, that is why I do not need to change the units, 300 ml by 3 ml into 8 minus 2, 6 milligrams per liter of oxygen. So, here it is 100, so it ends up being 600 milligram per liter of dissolved oxygen in terms of oxygen demand. So, the BOD of the sample is going to be equal to 600 milligram per liter. Let me see if I have another question. Okay, I seem to be moving on to another aspect. So, I want to slightly change the previous question. Instead of saying that it is 0, if I say that the BOD of my particular dilution water is, let us say 0.5 milligram per liter, how will this system change, right? Let us also look at that. So, I will have to, instead of 0.5 here, I will have to put in, instead of 0 here, pardon me, I will have to put in or plug in 0.5, right. So, as you can see, then the BOD of your particular sample is going to be lesser, right, because this mass will go out here and we have to subtract it. Let us see if I can do that out here. So, 300 into 6 minus 297 by 2, right, whole divided by 3, let us say, right. So, that is what it is going to be equal to, the BOD of my sample. So, this we know is 600 minus 297 by 6. So, let us say, I mean I should not make it 300, but okay, let me try to calculate, or if I make it 300 for easier calculation. So, it will be 50, 600 minus 50. So, I will end up with 550, I guess, right, or it is maybe 49.5 out here, right, maybe this is 49.5. Okay. So, what do we have? So, I see that if the dilution water had some BOD, I see that my sample BOD will be lesser than when my dilution water had no BOD. But again, that is just a theoretical case, assuming that the total change is still the same, right. That is just a theoretical aspect that I wanted to mention out here. So, I am almost out of time. With that, I will end the session, but again to repeat, we are not going to look at general formulas. So, here the approach is mass balance. I have a total that has dilution water, some dilution water and some actual waste water. So, here our approach is the total mass of the organic content, which I am measuring by the BOD in this particular mixture, is going to be equal to the organics in the dilution water plus organics in that small sample of your wastewater, and that is the approach out here, right. So, with that, again, as I said, I am going to end the session. Thank you.